We import FastAPI for the web framework, static files for serving assets, file response for returning HTML directly, Pydantic for data validation, joblib for saving and loading the trained model, numpy for arrays, random forest classifier as our ML model, datetime for timestamping energy logs, and JSON for data handling. This initializes the FastAPI application so we can define routes and handle HTTP requests. We initialize an in-memory device state dictionary with all for smart home devices defaulting to off, and an empty list that will accumulate energy consumption logs as devices are toggled. We attempt to load a pre-trained model from disk. If none exists, we generate 100 synthetic samples with temperature, humidity, and hour features, label them based on whether temperature exceeds 22 degrees Celsius, train a random forest, and save it to disk for future reuse. This get route serves the smart home dashboard by returning the index.html file directly as a file response instead of using a template engine. This endpoint returns the current on/off state of all for smart home devices along with a timestamp, allowing the frontend to poll and display live device status. This post route accepts a device name and Boolean state as URL path parameters, allowing the frontend to toggle any individual smart home device on or off. If the device exists, we update its state, simulate a random power draw up to 50 watts when turned on or 0 when off, log the reading with a timestamp, and return a success confirmation, otherwise we return an error. This endpoint accepts optional query parameters for temperature, humidity, and hour, defaulting to comfortable midday conditions, runs the ML model, and returns whether the AC is recommended along with the model's confidence score. This endpoint calculates the total and average power consumption across the last 10 energy log entries and returns them alongside the raw history, giving the dashboard a rolling energy usage summary. This endpoint returns the current automation settings, a target temperature of 22 degrees Celsius, smart lighting enabled, and an active schedule window, which the front-end uses to display the home's automation configuration. Now here is our index.html where I have designed the all-user interface. If you would like access to this code, just send me a message on our Discord server.